Welcome to lesson 5 of unit 7. So we're kind of getting over the hump. This is all about the laws of logarithms. So it's very, very much tied to our exponent laws. So you might notice some similarities. That's my strongest recommendation, is kind of watching out for some similarities that might help this be a little bit more easily remembered, so that when it comes to the exam, you aren't giving these on your formula sheet. You are responsible for knowing them, which also means that getting some good practice in is strongly recommended. So doing the homework for this one is a good one to do too, just like our previous lesson. So first of all, we need to know that in order to have a value in a log, we need the number to be positive. So we see that in terms of this notation here, both x and y are greater than 0. And we saw that on our graphs last time, in the sense that when we drew them, I'm just going to sketch it over on the side here. Again, we got this shape here, roughly. So again, x is always positive. Y, because of where it's placed in these particular notations, also has to be positive, not in reference to the graph. Okay, so our product law, just like when dealing with exponents, we said that x to the n and x to the m equals x to the n plus m. Okay, similarly, if we have two values being multiplied within a log, we can write it as the sum of each one. So we're kind of breaking it apart. Okay, we also had x to the n divided by x to the m equals x to the n minus m. Conversely, if we have two values dividing within a log, we can rewrite it as subtracting them. And the denominator is our second one. So denominator subtracted from numerator. And finally, our power law, and this one's a little bit weird, is that we can actually bring the power out in front. And that kind of stems from what we were seeing when we were working with logs, and the idea that we could rewrite it as, if we wrote like log base 3 of 3 to the 5, and we said that equals 5. Well, where that stems from, another way of thinking about it, instead of rewriting it as in its exponential notation, is we can think of it, if we use this law, we bring the 5 out and we leave log 3 of 3. Using this law to bring the 5 out in front, anything to the power of 1 is itself. So now I'm left with this whole piece being equal to 1, and all I'm left with is the 5, which is what I had said it was equal to begin with. So that's kind of where that law stems from. That's its origins, and that's kind of how it works. So if you get stuck on that one, going back to that idea from our last lesson of being able to rewrite it as a matching base, and then the exponent being kind of our final value. Okay, so again, the exponent of my power can be brought out front. So if you want to take a second and try some of these on your own to apply the law, go ahead. I'm going to walk you through a couple just to kind of identify which laws I'm using. So first of all, make sure that you note that it says simplify each expression. That means I'm just trying to combine things and make them into a single log, kind of like in our trig unit, how we would try and combine things to make them into a single trig function. That's my goal here, as a single log. You can then use your calculator to verify the answer because these are all base 10, so you can just punch them in. So this isn't necessarily something that would show up on the calculator section of the exam, but since we're learning, getting comfortable with this idea and just verifying that these laws are true, and just kind of getting comfortable with that idea that, yeah, they do work no matter what the numbers are, is going to be helpful maybe in terms of you feeling confident in your use of them. So whenever I see adding, I know that that's my product law. If I see a number out in front of a log, I know that that can be applied to my exponents. And subtracting is a quotient. So I'm just going to go through to identify those laws first. Again, fraction out in front, or any sort of value out in front, is my exponent law. From there, if I know I'm talking about products, I know I'm multiplying. Seven times 8. And so I could even rewrite this as log of 56. If I wanted to check this on my calculator, what I would do is I would type in log 7 plus log 8, and I would get, and this is my check, 1.7481888. Okay. If I punch in just log of 56, I do get the same value. So that kind of proves to me in my head that this product law does work. Okay, our next one, I'm just going to rewrite this as an exponent, so log 2 to the power of 5. And what we're seeing here is that can be rewritten as log of 32. Again, you can check that on your calculator, type this in. One thing that I do want to draw your attention to, I'm not sure that all calculators do it, but I know the one that I use does, is that when I punch in on my calculator, that log button, what shows up on my screen is log and then open bracket. Make sure when you're typing in, like for example, this first one, log 7, that you close the bracket and then hit plus, and then type in your second one, because if you don't do that, you've got a log within a log, and that's just making things overcomplicated. So how I would type it in would be log 7, close bracket, and then the plus log 8 part. Okay, so just kind of as a note. So, quotient law, got log, and then I'm going to go 80 divided by 16, which is 5. And again, you can punch this into your calculator, and for both sides, you should get 0.69897. Right here, log of 100 to the power of a half. If you remember, that's the same as taking the square root, if you want to write it like that. The square root of 100 is 10. And remembering that this is all base 10, 10 to the power of 1 gives me 10. So log 10 will always simplify to just 1. So whereas these ones all had to simplify to a value and then I'd use my calculator, Anything that has to do with 10, I can actually just simplify there. Finally, we've got log 6 to the power of -2. Again, negatives mean fractions. Log 1/36. Rather, negatives mean reciprocals, which ends up being a fraction in this case. Okay, and I would have to punch this in. That would be my simplified, that's as simplified as I get. Punching that into my calculator, I could go log of 1. And again, remembering that depending on your calculator, it already puts in the bracket for you, so that's kind of nice. And we get a value of -1.5563. Okay. So example 2, if you didn't pause for the first one, I definitely recommend pausing for this one. Try and apply your rules here, and we'll go from there. Okay. So again, the second that I have a common base, I'm good to go. So that's nice to know. I'm recognizing that within this one, I've got my exponent law, but then for the whole thing, it's product. So I'm going to be applying more than one law here. Log of x times y cubed. That's what that simplifies to be. Here I've got exponent law, quotient, and then product. And you don't need to be labeling these, just for kind of reference sake for our lesson. So when I go to write this in, I'm going to have x out in front. Then I'm going to have, and it really doesn't matter technically if you've got the x in the numerator or not, because we all know that multiplication and division, it's just bedmaths. It tells us that order isn't as important with those two. It's kind of just whichever one you do first, as long as they're together. So we can have x, y squared divided by z to the power of 4. Okay, so here is where it gets a little bit tricky. We don't actually have base 2. Not both terms have logs in them. So with respect to writing it like this, there's not a whole lot you can do. What you can do is you can introduce the idea of, well, log base 2 of 2 is equal to 1. And then we could rewrite it from there. But otherwise, that notation kind of would have been stuck as it is. So the only way to be able to kind of rewrite this as a single log is to introduce that value of 1. Kind of like when we were in our trig identities unit, we would like multiply by quote unquote 1 by multiplying the numerator and the denominator by the same thing and doing an equivalent fraction. Same idea. So what we get here then becomes, this is an exponent law followed by a quotient law. Oops, let's put a bracket. So I'd get log base 2, don't drop that base, 6 over 2 to the power of 3. And you could even simplify that as log 2. This is going to be 8, and so you could reduce that fraction to 3/4. That would be my answer. Okay. This one here, noting that when we talk about product law and allowing us to break them up and add is not the same thing as looking at this and being like, oh, well, that's the same thing as multiplying x plus x times 1 within my log, because it's already within my log. So I cannot simplify those pieces. So that's a really important thing to note, because a lot of people get tripped up on that. But I can still use my quotient law piece. So basically all of this over here is going to be in the denominator. And why I know that is because I could rewrite this as log x plus 1 minus, and factor out that negative from both of these remaining terms. 3 log 2, oops, y minus 2 minus 2 log z. Sorry, that would be plus, because I took the negative out of both of them. So that puts them together, which means that these are now multiplying, and that it's the whole thing. It's the quotient. So when I rewrite this as a single log, x plus 1 is in my numerator, not denominator, numerator, and everything over here gets simplified into the denominator. So I've got two exponent laws going on here. I've got y minus 2 cubed and z squared. That all goes in the denominator because it's all being subtracted from that first term. Okay, so that would be the difference between this example here, where they're both subtracting, and this example here, where the first two terms are adding, and then just the last term is subtracting. So again, I can apply the same rule here, where both of these are in the denominator, and then these two terms are going to be in my numerator. So how does that simplify it? Well, it goes something a little bit like this. This is not going to be super pretty, but so I'm going to write it a little bit bigger. It's going to be x to the half and a to the 5 divided by y squared and z to the 1/7, not to the 1/7. That would be my final answer. So again, it's not pretty, but if you had any variables that were the same in here, rewriting it like this would allow you to then simplify. So that's where these kind of principles and this practice would be helpful. Conversely, we can work backwards and expand logs. Sometimes this is helpful if we have a variable in with numbers and we want to be able to solve for that variable and isolate it. So just kind of bearing that in mind. So if you want to pause the video here and give this a shot on your own, I don't think that that's necessarily a bad idea. I'll do the first two without much explanation, and then the last one I'll break it down for you. So this last one, again, anything that's in brackets that's being added and subtracted, they don't fit into our laws because it's not a product or quotient or an exponent. So each of these sets of brackets is going to remain as they are. So this one's obviously not in terms of A, B, and C because we don't have A, B, and C. We've got X, M, and N, but the same principle applies in that we're going to try to rewrite this using our laws. So if you want to do it in steps, what it might look like is just identifying like, okay, quotient. So I'm going to break it apart and I'm going to have this and I'm going to be subtracting everything after it. So log of x plus 1 squared minus log of everything in the denominator. Okay. From there, I can identify that we've got an exponent law here, and we've got a product law here. So my next step is to address those two pieces. So I'm done with this first term now, which is kind of nice. Minus log of m plus 1 squared plus log n minus 3 to 4. Again, simplifying this further, I can distribute that negative through the brackets, or expanding it further rather, not simplifying, reverse of simplifying. This in terms of like appearance looks way more intimidating to me. Not simple. And finally, we have those exponent laws to address. So when you're doing these questions, you by no means have to write in which law you're using. I'm just doing that from an instructional standpoint. You can skip right to the part where you're actually just rearranging the expression. And this would be my final answer. Okay, so you may have been able to get there in fewer steps than I did. I was just breaking it down, this particular one down for you so that you could see how exactly it looks to show each individual step, and also to really emphasize again that those pieces that were in brackets stayed in brackets because they are not multiplying, they are not dividing, they do not have an exponent, and so they don't fit into the category of any of our three laws. I can't break them down any further. So our last example here is looking at the expressions and actually trying to evaluate them. So you'll notice again that we're looking at common bases. This is a really, really important thing to look at. Just like with exponents and powers, is that when you're working with our laws, we need that common base to be present. Once we're there, we can start rewriting and using our laws to try and condense things. So again, I'm going to identify that this is going to use my exponent law, and then overall I'm dividing, so this is going to be quotient. In terms of evaluating these, you may also notice that it becomes a little bit easier if you have a calculator. They're more likely to show up on like the multiple choice section of our calculator part than any other part of the exam, but it's not a bad practice to try and do it without, just in case they throw a random question at you related to logs that you have to think your way through a little bit more and just like explain, which is something that can show up on the non-calculator part of the exam. So I'm going to rewrite this first of all and foremost. Log base 9, don't forget your base if you're working with something that has 1, and it's going to be 6 to the power of 3, which I'm going to have to figure out in my head, and 72. That's what we're looking at here. So again, calculator would probably be something that we'd want to use here, but because it's base 9, I can't just press the log button. So that's something I'm just going to note over here. And that rule applies for pretty much any number other than 10. So instead I'm going to try and figure out, okay, well, what can I do with these? So I can rewrite it, log 9, and see what I can figure out. Well, 6 to the power of 3 would be the same as 2 to the 3 times 3 to the 3. And this is actually the same as 8 times 9, which is 2 to the 2, times 3 to the 2. And I'm getting this from, again, 6 is 2 times 3 cubed, and I'm allowed to distribute that into my product in there. Again, 72 is 8 times 9, oh, and sorry, that's 2 cubed. So it's a good thing I stopped to explain that one so I could catch my mistake. So once I've broken it apart like this, these cancel out. Using my exponent laws, I'm going to subtract, and I'm left with just log of 9 is 3. But I know that 9 is really 3 to the power of 2. So in order to get rid of that 2, I would have had to take half, and so that would have to be my exponent. Okay, and again, at this point, if you're not quite comfortable with log notation, you can rewrite things for yourself as 3 to the 2 equals to the power of n equals 3. Because again, base value exponent and solving for n then would mean 2n needs to equal 1, because that's my exponent over here. So n had to equal a half. So you could do this side note stuff, but just don't write it into your expression here, because this is technically a different way of thinking. We've introduced an equal sign and created an equation where we only had an expression before. So this has to be just scratch notes on the side. Okay, so again, if you want to pause and give this one a shot on your own, you're more than welcome to. I've got exponent laws in these first two. This is going to be in the denominator. And then these other two pieces will be in the numerator. So when I write it out, again, not forgetting my base, so I'm not going to be able to use a calculator again. I'm going to have 6 to the power of 2 in my numerator times 12 all over 3 to the power of 3. So I'm going to try and write this as like 3s and 2s just to help myself out a little bit and see what I can cancel out and simplify. So I've got, again, 6 is the same as 2 times 3 squared, and then 12 is actually 3 times 4, or 2 squared times 3. So bearing that in mind, I can rewrite this as 2 squared times 3 squared times 2 squared times 3, all divided by 3 cubed. If I tried to simplify this further using my power laws inside the brackets, I've got 2 squared is 4 and 2 squared is 4, so that's 4 squared. And then 3 to the power of 3 over 3 to the power of 3. And those guys cancel out. So now I've got log 4 to the 2. And I can do one of two things. I can bring that exponent out, or I can just recognize this from my last lesson, that when I have a power with a common base to my log, that the value is just the exponent, or I can bring out that 2. And I know that this is 1, just like I knew that this was 1. So my final answer would be 2. Either strategy would work for this part. Okay, so that's our last example. Again, I'll be posting some homework to go along with this to give you guys some practice. I strongly recommend doing some practice with this so that we get really comfortable with that idea of like using these laws and again manipulating these logs. If you have any questions, let me know.